Welcome to PanGlobal's Correction Series, which features typical calculation problems and their suggested solutions from our subject matter experts. In this video, we will work step by step through a problem that our technical staff have devised to help you apply the knowledge and concepts gained from your PanGlobal learning materials. This week, we are looking for an example for power factor in alternating current. Power factor is the measure of efficiency in a circuit and will be determined by the type of load that is connected to the circuit. Two types of loads can offset or distort the peak timing of voltage and amperage from maximum values by virtue of energy storage. In other words, the volts and amps are not in phase with each other. Power factor can be calculated by the ratio of true power in watts over apparent power volts amperes reactive in vars. Put another way, true power in watts divided by the apparent power in volts amperes reactive vars will give the power factor of a circuit. Power factor can also be derived from the cosine of the phase angle between peak volts and peak amps in a circuit. Power factor can be classed as unity, lagging, or leading depending on the type of load that is connected to the circuit. Power factor at unity. In purely resistive circuits where the voltage and the current peak at the same time, they are said to be in phase. Power is a simple calculation of volts multiplied by amps to derive watts. As an example, power flowing through a stove element is moving through a resistive load, so neither the voltage nor the amperage peak timing is altered. The voltage and amperage are in phase together. Lagging power factor. Inductive circuits create a lagging power factor when generating and sustaining a magnetic field for an induction motor. The voltage first builds to a peak value before the current rises to its peak value. The phase angle between these peak values is measured in electrical degrees, in which one cycle is 360 degrees. If you take the cosine of that angle, you will have the numerical value of the power factor, which then can be used in power calculations. Corrections to lagging power factor can be made with capacitor banks or the operation of a synchronous motor in an oversighted state. Leading power factor. Capacitive circuits create a leading power factor when connected to a capacitive load, such as a capacitor or synchronous motor with high excitation. The amperage first builds in this circuit to its peak value, followed then by voltage building to its peak value. As in circuits with a lagging power factor, taking the cosine of the phase angle between these peak values will derive the power factor in this type of circuit. Power calculation in a single phase. For this example, suppose there is a 30-degree angle between a circuit with 2,400 volts and 30 amps. Pause the video to attempt the solution on your own, or continue watching for the solution. Start with identifying the known variables and formulae required to calculate unknown variable and the answer. The circuit delivers 2,400 volts, represented by an uppercase E, with a current of 30 amps, represented by an uppercase I. The lowercase Greek letter theta denotes the circuit angle of 30 degrees. The power factor of this circuit, PF, has not been provided, but can be calculated. We need power factor to calculate the true power of the circuit in watts, represented by an uppercase P. According to the power factor formula of a lagging or leading circuit, we need to take the cosine of the circuit angle. The cosine of 30 provides a power factor of 0.866. Now that the necessary variables have been calculated, the apparent power can be worked out by multiplying the circuit's voltage, amperage, and power factor. Doing so provides a true power of 62,352 watts, or 62.352 kilowatts. The same circuit at unity power factor would be 72,000 watts, or 72 kilowatts. To double-check our work, we should use the power factor formula identified in the introduction. Taking the true power of 62,352 divided by the apparent power of 72,000 watts, we find a power factor of 0.866. This matches the power factor calculated from the electrical angle. Additional notes. Power calculation in a three-phase circuit. For calculations involving three-phase circuits, a modified formula is used. Power is equal to the square root of 3 times the voltage times the current times cosine theta, the electrical angle. If the circuit used in our example had been a three-phase circuit, the true power calculated would have been 108 kilowatts. Memory aid for students. Eli the Iceman is a mnemonic which can be used to remember power factor relationships. Eli, the voltage E, leads the current I in an inductive circuit, L. Ice, the current I leads the voltage E in a capacitive circuit, C.